Hello friends, I welcome you in lecture number 3 on permutations and combinations. In previous two lectures, we have taken the idea of permutation, and in this lecture, we are going to focus on understanding of combinations. So before going for the definition of combination, we first recall that permutation is nothing but arrangement of objects in which order is important. So we have considered permutation as an ordered arrangement of given objects or order arrangement of objects out of given objects, and the number of permutations of n objects taken r at a time is given by npr equal to n factorial divided by n minus r factorial. Now suppose order is not important, then what will be the number of arrangements of given objects out of total number of objects? So that if order is not important, then comes the idea of combination. First we understand with example. Suppose I am taking three objects, say A, B and C, and suppose I am interested in the arrangement of all these three objects. So if order is important, then we had seen that we have different arrangements: A B C, A C B, B A C, B C A, C A B, C B A. If order is important, then we consider all these arrangements as different arrangements. This arrangement ABC is considered as different arrangement from ACB. If we consider BAC and BCA, and they are considered as different arrangements if order is important. So these type of arrangements are called permutations of all these three objects. So there are 6 permutations of these three objects. Now suppose order is not important. Now if order is not important, then you can see we will consider all these arrangements as equal. So if order is not important, then there is only one arrangement of these three objects. So if order is not important, then we are getting only one arrangement, and that arrangement is known as combination. So we have only one combination of three objects, and we have 6 permutations of three objects. We can have arrangement of 2 objects out of these 3 objects also. Suppose order is important, then we have seen that we consider AB and BA as different arrangements, then BC and CB as different arrangement, AC and CA as different arrangements. So there are 6 permutations if order is important. This we have seen in lecture number 1. But suppose order is not important, then we can see that these two are considered as same arrangement. AB and BA are considered as equal if order does not matter. Similarly, BC and CB are equal, and AC and CA are equal. So we have 3 arrangements if order does not matter. So we can say that there are 3 combinations of 3 objects taken 2 at a time. And here we can say that there are 6 permutations of 3 objects taken 2 at a time. So there are 3 combinations and there are 6 permutations. So because here order is important, these are considered as different arrangements, and because here order is not important, we consider AB and BA as equal arrangement, BC and CB as equal arrangement, CA and AC as equal arrangement. So this is the idea of combination. A combination is an unordered arrangement or unordered selection of some objects out of given objects, and the number of combinations of n objects taken r at a time. Suppose we are interested in the selection or arrangement of r objects out of total n objects, then that number of arrangements in which order is not important is given by NCR, that is n factorial divided by r factorial times n minus r factorial. This is the formula for the number of combinations of n objects taken r at a time, or this gives us the number of ways in which we can arrange r objects out of n objects in which order does not matter. So this is the idea of combination, and I hope you are now familiar with both the concepts. Permutation and combination both are arrangements. In permutations, order matters. In combinations, we are not giving the importance to the order. So here order does not matter, and in permutations we consider the ordered arrangements. So that is all about combination. I have written the definition. Suppose we have a collection of n objects. A combination of these n objects taken r at a time is nothing but any selection or any arrangement of r of these objects where order does not count. So a combination is also one type of arrangement or selection in which order does not matter. And as I discussed, the number of combinations of n objects taken r at a time is denoted by these different notations, NCR or CNR. Some authors are using these different notations, and this is the formula for NCR. So we consider some examples related to counting the number of combinations. Instead of using this formula every time, we can use this type of calculations also. For example, I am interested in the calculation of 4C2. So if I go by this formula, I will write 4 factorial, r is 2, so 2 factorial, and 4 minus 2, that is n minus r. So this is 4 into 3 into 2 factorial. Here 2 factorial into 4 minus 2, that is 2 factorial, and this 2 factorial is equal to 2. So here we will have 2 into 3, that is 6. But instead of going in this way, what we can remember is, because I have r equal to 2, I must have 2 terms in the product, in numerator as well as in denominator. So here I start with 2, here I start with 4, and because I must have 2 terms in the product, I will subtract 1 from previous term. So if I subtract 1 from 4, I will write 3 here. If I subtract 1 from 2, I will write 1 here. And now I have 2 terms in the product. So now I stop here and I consider 2 into 3 equal to 6. Suppose I have 4C3. So if I am having r equal to 3, I must have 3 terms in the numerator as well as denominator. So here I am writing 2 and 1. I am subtracting 1 from each of the previous number. Here I will write 3 and 2. So this turns out to be 4. Similarly, suppose I am interested in the calculation of 7C4. So because r equal to 4, here I start with 4, here I start with 7, and because r is 4, I must have 4 terms in the product. So I will write 3, then 2 and 1. Here I will write 6, 5 and 4. 4, 5, 6, 7, 4, 3, 2. So this is cancelled and we are left with 35. So either we can use this formula directly or we can go in this way also. Now we consider this example. How many committees of 3 can be formed from 8 people? We have total 8 people, that is total number of objects are n equal to 8, and we have to construct r equal to committees of 3 persons. How many committees of 3 persons can be formed from 8 people? So there are different ways of selecting 3 people out of 8 people. So we have to decide the total number of selections of 3 peoples out of 8 peoples. And it is a common sense that while constructing or selecting the persons from given total number of persons, here order is not important. Okay, it does not matter that which person is selected, so order is not important. Therefore, this is the problem of combination. So we have to decide the number of combinations of 8 objects taken 3 at a time, and that is given by 8C3. And this we can calculate as, because I have 3 here, I write 8 here, and 3, 2, 1 here, 8, 7 and 6. So this 6 will get cancelled and we have 56. So there are 56 different committees of 3 persons which can be constructed out of 8 persons. So we have to write systematically. Each committee is essentially a combination of the 8 people taken 3 at a time, and the number of committees that can be formed is given by 8C3, that is 56. So here we have to decide that whether this is the problem of permutation or combination, and that depends on the order. So we have to decide whether order is important in the given or in the arrangements which we want to construct. If order matters, then we will use permutation. If order does not matter, then we will use combinations. So we have to decide whether we have to use NPR or NCR. For example, suppose we have given 3 digits, say 2, 7 and 5, and they ask us to construct the number of 2-digit numbers that can be constructed out of these 3 digits. How many 2-digit numbers can be constructed out of these 3 digits? So here you can see that order is important. For example, if I consider 2 and 5, then 25 and 52 are different numbers, 2-digit numbers. So here, to count the number of 2 digits or to count the 2-digit numbers, order matters, and therefore we have to use the formula of permutation, that is, that number is given by 3p2. So in that way we have to decide whether order is important or not. In this case we have 8 persons and we have to select 3 persons out of those 8 persons. So here order does not matter. Suppose I have 3 persons are denoted by P1, P2 up to P8. So whether I am selecting P1, P3, P8, suppose I am selecting these 3 persons, and another arrangement is P3, P1, P8. So these two are considered as equal. Here order does not matter. We are interested in the selection of 3 people. Either I consider P1 first, P3 first, or P8, or if I select P3, P1 and P8, these two arrangements or selections are considered as equal. So in this problem order does not matter, therefore we have to use the formula of combination. So whenever you have the problem of permutation or combination, you have to decide that whether order is important in a given particular problem or order is not important in a given particular problem. I have taken another example of combination. A farmer buys 3 cows, 2 pigs and 4 hens from a man who has 6 cows, 5 pigs and 8 hens. How many choices does the farmer have? So here you can see total number of cows are 6, and out of those 6 cows we have to consider selection of 3 cows. Similarly, total 5 pigs, and farmer buys 2 pigs out of 5 pigs. Similarly, there are 8 hens, and farmer buys 4 hens. So 3, 2, 4, and 6, 5, 8. So this is simple problem. You can see here, to select 3 cows out of 6 cows, order is not important, and the number of selections of 3 cows out of 6 cows are given by number of combinations of 6 objects taken 3 at a time. Similarly, farmer can buy 2 pigs out of 5 pigs in 5C 2 ways, and similarly the farmer can select 4 hens out of 8 hens in 8C 4 ways, and farmer want to buy all these three type of animals. So all these 3 tasks are necessary. So this is the application of product rule. Also we can consider the task of farmer in 3 different tasks. Suppose task 1 is to select 3 cows out of 6 cows. Task 2 is selection of pigs, and task 3 is selection of hens. And farmer want to buy all these 3 types of animals. Therefore, we have to apply product rule. So the number of ways farmer can select cows are 6C3. The number of ways farmer can select pigs are 5C2, and the number of ways a farmer can select hens are 8C4, and therefore by product rule the total number of ways of doing all these 3 tasks are given by product of these 3, and that I have calculated here. So we have to write systematically that the farmer can choose the cows in 6C3 ways, the pigs can be chosen in 5C2 ways, and he can select hens in 8C4 ways. Therefore, by the product rule for counting, the farmer can choose the animals in 6C3 into 5C2 into 8C4. For 6C3 we have to write 3 terms in the product. So here 6, 5, 4 and 3, 2, 1. Then 5 into 4, 2 into 1, 8C4. So 4, 3, 2, 1, 8, 7, 6, 5. And if you simplify all these things, you can see this 6 will get cancelled. Here we have 20. Here we have 5 into 2, 10. And here we have 6 cancel, 4 cancel, and 7, 0. And that turns out to be 1400 ways. The farmer can buy in 1400 ways these different types of animals. So this is about the understanding or concept of combination, and now we are familiar with both the concepts, permutations as well as combinations. Here order is important. Here order does not matter. So whenever we have order arrangement, we will use permutation, and if we want to select R objects out of N objects, we will use formula of NPR. Here we will use formula of NCR. This is given by N factorial divided by R factorial times N minus R factorial, and this part is nothing but NPR. So we can write this formula as NPR divided by R factorial also. So we will continue with this in upcoming lectures. Thanks for